All right, guys, this is your last set of notes for chemistry, and we're going to be looking at the types of reactions and discussing the law of conservation of mass again. Even though we've talked about that, it's a really important law, so we're going to talk about it again. This is on pages 174 and 175 and pages 180 and 181. Your reading goals, you need to describe how mass is conserved in a chemical reaction and describe the three types of reactions. You'll need to define the law of conservation of mass and give an example, top of third flap. You will need to create a double bubble map comparing and contrasting an open versus closed system, top of the third flap, and then create a tree map of the three types of reactions with descriptions and examples. Pictures could be very helpful here, and that will be at the bottom of the third flap. So let's start with the law of conservation of mass on your first set of pages. And we've talked about the law of conservation of mass before. So we know in a chemical reaction, no matter is created nor destroyed. And that seems pretty logical. But sometimes, like when a chemical reaction occurs, like burning logs, it seems like it's going away. Okay, but it's not. Just some of it's being converted into a gas that we can't measure at that time because it's in an open system. But another way of saying this is all the atoms present at the start of the reaction are going to be present at the end of the reaction. So in this little picture of the little flasks, and they have they're sealed up. Okay, so if we have 10 grams in the first flask, 10 grams in the second one, if we mix them together and a reaction occurs, there's going to be 20 grams. And so the same thing occurs. Remember when we did the gas has mass lab? We tried to create a closed system where we sealed up the baggie. It's where we mixed the baking soda and vinegar, and the bag kind of blew up, and then you had to weigh it to show that even though the baking powder and vinegar had kind of gotten smaller, the gas still has mass in the system. So there wasn't anything created or destroyed. There's the same amount of matter there. Okay, so let's talk about an open versus closed system that I keep talking about. So both of these systems are where chemical reactions occur. In an open system, the matter can enter or escape from the system after the reaction. So that's what makes it seem sometimes that matter is being created or destroyed, even though it's not. In a closed system, if we were able to close all the systems that chemical reactions occurred, you would see that matter does not enter or leave, and it's going to have the exact same mass. And you can see the little picture of the balloon on the flask. That's one way of kind of creating a closed system. And so you'd have to have like truly a sealed airtight container. So like the gas has mass lab that we did, or even this balloon flask, a little bit of gas is probably going to escape because it's not airtight. But it's important to know that no matter what, it has to be equal on both sides. So even though a completely new substance is formed, the mass is going to stay the same. All right, now there are three main types of reactions that we're going to talk about. One is called synthesis, and this is when you have two or more elements that combine to form one complex substance. Synthesis means to combine or put things together. And so you can look in the picture here, it's like A plus B creates AB. Okay, so that would be a visualization of how synthesis works. You have one substance plus another substance creates one whole. Okay, so two different things creates one whole. All right, then we have decomposition, which is the exact opposite of synthesis. This is when a compound breaks down into simpler substances. Okay, so you would have BC creates B plus C. Then we have replacement, and there's single replacements and there's double replacements. Single replacement is when one element replaces another in a reaction. So a way of visualizing that is AB plus C would react and it would yield A plus BC. So you can see how the B moved over to the C. So there was one exchange or one replacement. Now in a double replacement, elements in one compound completely trade places with another element in the other compound. Okay, so it would be like AB plus CD yields AD plus BC. Okay, so they completely swap out. All right, and then there's actual examples of those in your book that you can write down. Using the visualization, those little pictures that I have of the A plus B yields AB, I think those are really helpful, and so you might want to add those to your notes. Now, this last slide here, one of the assignments that you're going to be working on in class on Friday is you have to create with a group a metaphor project for the 4 different types of reactions: for synthesis, for decomposition, for single replacement, and for double replacement. And so I'm kind of doing an example here of how yours might look, but looking at these pictures, the first one, what type of reaction is that? I want you to kind of study that picture and decide what you think it is. We're going to talk about it in class. Then I want you to look at the second picture. We have an egg, and then it produces a broken egg and a chicken. Okay, what type of reaction might that represent? Okay, then we move down to the third picture where one guy swaps out for another guy. Okay, and then the last picture, we have one creature plus another creature produces this big kind of one creature of the 2 together. So what type of reaction do you think that represents? So these are all kind of metaphorical representations of the different reactions just to help you understand what's happening when compounds combine. So think about those. We'll talk about them in class on Friday, and then you're going to be creating your own metaphors in a group.